Now, concentration of the ore. So first is I will take the magnetic, what you can say, separation. Now where we go for magnetic separation? Where the substance is magnetic in nature, I mean the metal is magnetic in nature, or the impurities is magnetic in nature. Alright, either of this. Either the metal is magnetic or the impurities are magnetic in nature. Now what we do that? What we are doing in it? See, there we are taking a conveyor belt. Here this is the pulley of the conveyor belt. This is another, that is conveyor belt, we are taking it. So this is the belt, we can say that. Alright, this is a pulley and this is your conveyor belt. Now here, that is, we are having the railway tracks, and below the railway tracks we have put a trolley. Alright, we have put a trolley which is moving, of course, the trolley is moving over the track. Alright, the trolley is moving over the track, we can say that. This is a track and the trolley is moving over upon it, we can say that. Clear? Upon this track. Now, what we do? We will put the ore here. The ore, we are going to put it here. The for the concentration purposes, we are going to put it. The pulverized ore. Now, what do you mean by the word pulverized? Means we are breaking the ore. For example, iron ore. Iron ore means you will be getting in big rocks. You will break it up into small pieces. Alright, small pieces. That is called pulverized. Alright, so you will break it up into small pieces and you will put it. You will pour it from here. You will put it here. Now this particular belt is moving. Constantly it is moving. So what you will find is that, and this is electromagnetic. This pulley are electromagnetic in nature. These two pulleys, they are electromagnetic pulleys. We can say that. And constantly this belt is moving. We can say that. Now when you are putting here in the belt, what you find, the ore particles will come here. The ore particles will come down. It is going to come down here. And this electromagnetic, this pulley which is electromagnetic, it is going to pull the ore particles towards, the iron ore particles towards itself. Basically, this process is being done for iron ore. Understood? Because iron is magnetic in nature, isn't it? Clear? And the impurities which are present here, impurities means the gang particles, the matrix which are present here, they are the non-magnetic. I said, you know, basically it is used to separate the magnetic from the non-magnetic particles. Either the ore can be magnetic, then the impurities is non-magnetic, or the impurities is magnetic, the ore is non-magnetic, whatever you can say. So in this way, we are putting the ore here, and so it comes down and is being pulled by this electromagnetic pulley, we can say that. So electromagnetic pulley, what it does, it attracts the iron ore towards itself. So iron ore gets collected here in the trolley. The iron ore gets collected here. In the trolley, it gets collected. Alright, now, and the trolley, it moves forward. This particular trolley, it moves. Another trolley again comes here. Again it moves forward. One, it becomes full. Then again another trolley comes. In this way, what you can say, the magnetic particles, the magnetic ore, that is the iron ore, gets collected in the trolley. Now what about the non-magnetic particles? Non-magnetic particles is not pulled by this particular pulley, isn't it? They are not pulled. So the non-magnetic particles are thrown here and there. They are not being attracted, they are thrown here and there. We are not interested in the non-magnetic particles, understood? The magnetic particles is being pulled by this electromagnetic pulley, and hence it falls down just below the trolley which is being placed below the electromagnetic pulley. So once the trolley is being full, the next trolley comes, empty one. Again it is being full, another trolley comes. In this way, what you find is that this process of concentration of the ore is known as electromagnetic separation, or simply we can say that magnetic separation. Basically, I said you already, it is being done to separate the magnetic ore from the non-magnetic particles, we can say that. Fine. Now next is your Froth flotation process. I think you understood this particular one. That is the magnetic separation. Now next is Froth flotation method. Now Froth flotation, let me say you, like in the previous concentration I said that it is being done for the magnetic and the non-magnetic particles. That is, to separate the magnetic from the non-magnetic particles, we go for the magnetic separation. Got it? Now, next is Froth flotation method. F-R-O-T-H. Froth flotation. F-L-O-T-A-T-I-O-N. F-L-O-T-A-T-I-O-N. Flotation. Froth flotation method. Achha. This is being basically done for the sulfide ores. Sulfide ores. Remember that. For which ore we are doing which particular process. It's not that for any ore, any process will do. It's not in that way. For sulfide ores, we go for Froth flotation. Now, for that purpose, what we do? We take a large tank in this way. A tank we take it. We take a large tank and we take, that is water. Yeah, we are taking it here, water, we can say, and this is your water. Fine. Now we are putting pine oil upon it. I am using different colors, you can see that. I am putting pine oil. Definitely oil and water will not going to mix. Now pine oil is an industrial oil. It is used for this particular purpose only. It is used for this particular purpose only. Pine oil is an industrial oil, we can say that. Clear? Now what we will do is that we will put the sulfide ore into it. The sulfide ore will put into it. Alright? Sulfide ore. Generally copper sulfide, zinc sulfide, lead sulfide, we can say that. Clear? I told you that. That is the name of the some of the, that is the sulfide ores, like zinc blend is called as ZNS. Then galena is your PBS. Then iron pyrites is FeS2. Cinnabar is HGS, we can say that. Okay. So in this way you will take the sulfide ores, alright, and you will put it into the mixture of pine oil and water. And here the pipe will be there, alright, a pipe will be there, and we will pass air under high pressure. We will pass air under high pressure, will pass into this particular mixture. Will pass air under high pressure, will pass into this mixture. Now what will happen is that the ore will get agitated, means it will mix up thoroughly. Alright, the ore will get agitated. Now we will put, to separate the ore from the gangue particles, once the ore gets agitated, it forms froth. Froth means foam, jhag. This is sabun ka jhag hota hai na, that's all. So it forms froth. Now froth is lighter, it is going to come to the surface, but it will not come by its own. It is not going to come by its own. What you have to do? You have to add a particular substance, alright, which is known as ethyl xanthate. It is known as what? Separator, which separates the ore from the gangue particles, from the matrix. Alright, that is a sulfide ore. Here O is what? Sulfide ore. So sulfide ore from the gangue particles, from the matrix, it is being separated by adding ethyl xanthate. Ethyl xanthate is a particular compound which acts as a separator, which separates, what you can say, the froth from that of the gangue particles. So the gangue particles are heavier, it settles down here. The gangue particles which are heavier, the unwanted particles, it settles down, and the froth, it's being collected here at the top. The froth, the sulfide ore, the froth, it is being collected here, we can say that. Now the froth definitely is lighter, it will rise to the surface and it will get collected. How you separate it? Mechanically, by the help of hand you separate it in this way. By the help of hand, mechanically we separate the, what you can say, the sulfide ore. Alright, so this process is called as froth flotation method, we can say that. It is known as froth flotation method. It is used for the sulfide ore, so to say, we can say. So next is your, what you can say is that gravity separation method, the hydrolytic method, we can say that. Gravity separation method. Now this method is used, you understand the method where it is used. Hydrolytic method or the gravity separation method is used where the ore and the impurities are based, what you can say, are differentiated on the basis of its density. Where the ore and the impurities are, what you can say, separated or distinguished on the basis of its densities. Let us say the ore is heavier and the impurities are lighter. Alright, the gangue particles, impurities are the gangue particles which are lighter. Alright, so for that particular purpose, what we'll do, we will, that is, construct a bed, this sort of. We will construct a bed, this sort of bed we will construct. Alright, just like steps, we can say that, we will construct a bed. Alright, this sort of bed, there is a rough diagram I am drawing here, just to make you understand. Now, this bed, what you can see is that this sort of bed, as you can see it here, it is having steps in it. The steps are there, a lot of more steps will be there. Now, what we will do is that, and here this we are having, there is a motor will be fixed here, so that this bed is going to vibrate. Now this bed is made up of wood, we can say that. It is made up of wood, this particular bed, we can say. So here we have put a motor here, got it? The motor will vibrate this particular bed, so it is going to vibrate this bed, we can say that. Clear? It is going to vibrate. Now we are going to put the, what you can say, the ore here. We are going to put the ore here. Now it is vibrating. Clear? So what will happen is that on vibration, the lighter particles will slowly will move out, but the heavier one will remain, isn't it? It's not going to vibrate so much in this way. It's a little bit slowly it's going to vibrate the petals. Alright, so in this way what will happen is that the lighter particles will just move out, will get separated, but the heavier one will settle there. Let us see. Now to completely separate it, what we are doing is that we are spraying water from here. Water is being sprayed from here. So when we are spraying the water, what happens is that the lighter particles is being carried away by the water. The lighter particles is being carried away by the water, but the heavier particles remains. Now you may ask me why the bed is being made in this way. Might be some heavier particles also will move out by vibration, or it will go out by the force of water. But suppose if the heavier particles come from here, it may stop here. It may stop here. If it is not stopping here, it may stop here. If it is not stopping here, it will stop here. So somewhere it is going to stop now. In this particular bed, somewhere the heavy particles will settle down. Suppose if it comes from above by the force of water, it is going to settle down here. Or if not here, if not here, it is going to settle down somewhere. But the lighter particles will be washed out. It will be washed away. Alright, the lighter particles, the gang particles. Like generally what we do is that in case of iron ore, when we are extracting iron ore from the earth's surface, it contains rags, twigs, clay, hair, paper, so many. These are lighter particles. So what we do is that we first put the iron ore here and we spray water under high pressure, and also it is vibrating. What happens is that clay, rags, twigs, hairs, all these are lighter particles, it is being washed away. Iron ore remains behind. Alright. In this way, basically this method is used for the gravity separation. Method is also said to be as, or hydrolytic method is also said as, because water is being used for this particular purpose. Now, next is what we find. Yeah, so what I said, the lighter particles, it is washed away. I don't want, and the heavy particles remains behind. Now next is your leaching or chemical method. Now leaching, where we use it? For example, you will see when I teach you for the extraction of aluminium, you will see that I will be using sodium hydroxide as a chemical. Alright, I will be adding sodium hydroxide to aluminium oxide. That is bauxite, so to say, not aluminium oxide. It is bauxite I will be adding. That is sodium hydroxide, I will add to bauxite to convert it into sodium metaaluminate. We can say that, to convert it into a particular compound. So this process is called as leaching. Now why do we do that? In leaching, what happens is that the metal, the substance, one of the substance which is a metal, we can say that, it reacts with that particular chemicals, but the impurities does not. In leaching, what happens is that the metals which is to be extracted, one of the metal which is to be extracted, that reacts with a particular substance and it forms, that is, a compound. For example, I gave you an example to you that we will take bauxite, we will put the bauxite into a tank which contains sodium hydroxide in it. Alright, now sodium hydroxide reacts with bauxite to form, that is, sodium metaaluminate. Now why it is so? The reason is that aluminium is amphoteric in nature. It reacts both with acids as well as with bases. Achha. With aluminium, listen carefully, with aluminium, the impurities which are involved, impurities are basically iron, copper, nickel, mercury. They are not amphoteric. They are not amphoteric. So they have got no reaction with sodium hydroxide. So they will settle down in the tank, in the sodium hydroxide tank, as an impurities, as a gang particles. And we will be getting sodium metaaluminate. Alright, I'll teach you in the extraction of aluminium, you will see that. So in this way, leaching is that particular process in which the chemical is used for the concentration purposes, so to say. A particular chemical is used, as I gave you an example. So this is all about your concentration of the ore. After concentration will come for the roasting and the calcination. Means in the concentration process we have converted the impure ore to a pure ore. We can say that. We have converted impure to the pure ore. Now it is our turn to convert the pure ore into its oxide. Why? So that it can be easily reduced, because after this next step is your reduction of smelting. Alright, so we need to convert it into its oxide, because you need to remember step by step. So roasting means heating of the ore in presence of air below its melting point to convert into its oxide. Again I repeat, roasting means heating of the ore in presence of air. Heating of the ore in presence of air below its melting point. It should not melt. The ore should not melt below its melting point to convert into its oxide, because my job is not to melt, my job is to convert the pure ore into its oxide so that it can be easily reduced. The next step is, alright, that is called as roasting. So roasting basically is being done for the sulfide ores. It is being done for example, ZnS plus O2 on heating will give you ZnO plus SO2. You can see that. So basically, sulfide ores upon heating in presence of air gets converted into its oxide. Now zinc oxide I can take it and what I can say, I can convert it into its metal by after reduction. So this is called as roasting. Now calcination. What is calcination? Either roasting or calcination, by which we convert the concentrated ore into its oxide. Now calcination is heating of the ore in absence of air. Heating of the ore in absence of air below its melting point to convert into its oxide. Heating of the ore in absence of air below its melting point to convert into its oxide. Basically, it is being done for the carbonate ores. Carbonate. For example, calcium carbonate. On heating, we will get calcium oxide and carbon dioxide. So this is being done. Roasting is done for the sulfide ores and calcination is done for the carbonate ores to convert it into its oxide. In both the case, I convert it into its oxide. You can see in both the cases, the product is my oxide. My aim is to convert it into its oxide. So I have converted it into its oxide. For the sulfide ore, I go for roasting, and for the carbonate ores, I go for calcination. You may ask, for the sulfate ore also, what we'll do? We'll go for roasting. Same thing, sulfate will go for roasting. For the carbonate ores, got it, we'll go for what you can say calcination. And for the oxide ore, not required at all. No need to do anything. No roasting, no calcination is required. Already it is in the form of oxides. And the halides ore, there also we can go for what you can say, that is roasting for the halides ores also. Alright, but basically the ore which you are going to study, alright, that is in your syllabus which is there, it is basically sulfide or carbonate, we can say that. For that reason I talked about sulfide and carbonate to you. Now, next is the third step is your reduction. The third step is a reduction. So what we do in reduction, we'll see in the next video.